Hi guys, this is Mrs. Gastler, and we're going to be looking through the information in your packet that begins on page 23 that's about using pie charts to represent energy. What I've got here in my picture is the first answer, the first solution to drawing a pie chart to analyze the energy of a ball that has been thrown upward from ground level, reaches the top, and comes back down. So this right here is like a comic strip showing individual points where the ball is, and then we've got a pie chart for each of those points to show what kind of energy there is. Now at the bottom, where it's on the ground, there's no gravitational potential energy. It's all kinetic, and so the pie is all kinetic energy. As we go up, more of the energy becomes gravitational and less of it becomes kinetic, and so the kinetic part of the pie is getting smaller. As we get all the way up to the top, there's no more kinetic energy because that ball has to stop before it comes back down. So there's all gravitational potential energy. And then as it's coming back down and it's speeding back up, that energy is turning back into kinetic. And then it's all kinetic energy when it reaches the bottom. So what we're doing is we're showing pies. An important thing to notice about this picture is that this part that is higher has more gravitational potential energy than this part that is lower. But if we could see this, if we could watch this change, you would just see that part of the pie get bigger and smaller, which you may have seen in the energy skate park if you looked at the pie charts that are associated with that one. Now the next example we're going to look at is a ball that is swinging. You'll notice that it starts up and it ends up down and has almost an identical look to these pie charts here. It's all gravitational at the top, all kinetic at the bottom, and it's gradually changing over as we go. If we could draw a GIF or something, we could show that pie chart changing gradually as it goes. But all we're doing is showing that the energy is there. Now here's one where a box is sliding across a rough surface and coming to a stop. This time it's not going up, so there's no gravitational potential energy. We have that kinetic energy and it's turning into thermal energy. If this was you sliding across a rough surface, you might get burned by the thermal energy. That's called rug burn. So we're just showing that the energy is changing. Now on the next page is Energy Pie Charts 1. There are some examples of what kind of situations where the energy is changing. Sometimes it's going to be easy and sometimes it's going to be hard. You need to say what you're going to include in the system. Remember that if you include everything in the system, then you can actually make sure all the energies are included. You also need to make sure you draw a key. So you're going to be shading in these boxes with whatever kind of energy it is. So maybe you have kinetic energy or stripes, and maybe you have gravitational potential energy is dots, and maybe you just leave it blank if it's thermal energy. However you want to do it, it doesn't matter to me, and we don't have to do it the same way because it's a key, as long as you have a key that shows what's going on. You'll notice that there's a key on every single one of these pictures, even on this question on the next page. Okay? So it's important that you are making an effort to think about what kind of energy is changing and what kind of energy there is. There's going to be more of those practice things for you to work on. If at any time you have a question, make sure you ask your teacher so that your teacher can help you understand it better. Thanks for watching.